Welcome back, you guys. Tonight we're going to be working on a Glock 19 Gen 4. And let me quickly take you through the process of exactly what we're doing so you have a better understanding of what you're viewing as it unfolds. Now, first and foremost, customer reached out to me and said they're interested in having their Glock 19 done. They had a design that was kind of in mind. They wanted to merge some things together and have a build done. And one of the key things that they wanted to have done on their build was they wanted to leave the existing dovetail where it is, but they also wanted to do a vortex on the back section of the slide. So, you know, we went down that path of educating the customer, letting them know that the distance between where the rear dovetail is and where the plunger is not big enough to support that optic, and what will happen is we will hit the plunger hole. So we have to make sure that we leave enough room in the back to support the dovetail where the dovetail won't come loose over time, and therefore that means that the optic itself is too long and we end up hitting the plunger hole. Now, we have a dedicated video out several months ago, 6 or 8 months ago, that really explains it in full detail, exactly, you know, how this works, why this works, and things like that. Now, I educated the customer a little bit and let them know that that could potentially be an issue. I have a lot of people that reach out to me that have had optic cuts done and say, I've got an issue with my gun. Can you look at this and tell me what's going on? I tend to stay away from the gunsmithing side of it, but it happens to be that this starts falling into what would be like the CNC or the cut side of it. So it's not that there's necessarily a fault in the firearm itself. It just happens to be that the process that was taken by somebody before me ended up causing a problem. Now there's an owner that doesn't have a slide that works. So I let them know that one of the options of something that we can do is modify your plunger. So let me explain that in short detail, and then we'll go into better detail here once we have some holes cut and we can take a look at everything. But basically the idea is as the optic sits on here, we cut into the plunger hole because the plunger hole's right there, okay? So as this is a full put together weapon, what we end up getting is this plunger doesn't work whenever we cycle it. So basically you fire around, it goes to the rear, and this doesn't actually end up doing a full stroke up into the inside up here because it can't, because it ends up hitting onto the bottom of the optic. So that causes several problems. One, we have an issue extracting. Two, we have an issue where you're just beating to death your optic. So the way to correct that is to modify the plunger itself to where the amount of distance that you've come down into the hole is how much you're removed from the plunger itself on the top side, so therefore you're not short stroking it and you're getting a full stroke. We'll explain this in better detail once we actually have a hole cut here, once we actually can see the plunger hole. I'll put the pieces back in and move them up and down. You'll be able to see exactly what I'm talking about, just in a little bit greater detail. So let's kind of get up to that point. Let's catch up to there, and then we're going to talk about that a little bit more. So what we're going to do is we're going to do a slide chamfer all the way around. We're going to cut this for the rear optic. Okay, we'll do some sandblasting. We're going to bring it back. Then we're going to discuss that. At that point, we will then move forward with the rest of the design, which is going to be like window, some serrations up here. We've got some top work we're going to be doing. We have some laser work that we're possibly going to be doing as far as some logo stuff goes. So we happen to have a lot going on here, but this is going to be kind of more of an educational period for the plunger hole because we've never actually discussed that before. So real cool opportunity to educate my viewers a little bit more about maybe what we do have as an option. I don't necessarily recommend it, but at the end of the day, if you must keep the dovetail and you must have your optic here, this may be a solution for you. So guys, let's get over to the Tormach 770. Let's go ahead and get that chamfer. Let's go ahead and get that optic cut in the back zone so we can go ahead and see exactly what's going on with that plunger. Let's bring it back. Let's discuss it. All right, guys, well, I wanted to bring you back, show you exactly how it came out. Now, we understand that when we go through the process of not moving the dovetail, ultimately we will hit the plunger hole, which we discussed in the beginning portion of this video. There's just no way around that. The only thing you can do is just not cut it as deep, and then you start going into issues where the rear iron sight cannot see past the optic because it's too high. So let's just talk about why this is a problem. We've got our plunger here, okay? So the idea here is that the plunger goes in this way, and we're just gonna kind of simulate this. Now, it's in much farther whenever it's held in place, so it's up in here like this. But the issue that you have is, as the weapon cycles itself, this ends up, I'm gonna have to use something to push in here a little farther, so we'll use this pen. As the weapon cycles, this plunger ends up going in and out of that hole, okay? It doesn't stay at the same height the whole time. It actually goes up and down as it extracts. And when it's in the top stroke or all the way compressed in the inside, it could go a maximum distance of this far. I'm gonna push it all the way in as far as it could possibly go. And what you're gonna find is, I can do this all at one time. Guys, I'm working behind the camera. Ooh, just bear with me here. See if I can use my hand a little bit here. What you're gonna find is that you see right there, it comes up just a little bit into the pocket. Not much. And it may never come that far up into it. Actually it will. There we go. I pushed it. I finally got it all the way up in there. I can flip you guys over. Okay. You see that? As I'm like totally holding this awkward. I'm sorry about that, guys, but see how it is up into that hole? That would be the maximum travel. So it is possible to go all the way up into where it would hit the bottom of the optic itself. So what you want to do is you want to end up taking this very carefully, and you want to pull the spring out. You don't want to lose that. This is important. And this would be the part that comes up in and would hit the bottom of the optic. What you want to do is you want to shave this off just a little bit like this. See where the black line is? I'm going to get you guys to focus a little better here. I'm going to give it a second. See there's a black line right there? The idea is that that's how much material we want to take off. Now, we don't necessarily need to take it off all the way around. We only have to take it off the amount of which goes up into the plunger hole. So what you'd find is that maybe half of this distance, something like that. So on the left-hand side, you can see it right here. Half of this distance is what we would have to come in. We don't necessarily have to shave the entire top off like this way. Does that make sense? So that would be the maximum amount that I can go up in there. Now, of course, as we shave that off and you put it back in the slide and you push it up in, it's going to appear as though, hey, we're in that zone again. We're going to be hitting again. But you have to remember that it's not actually going to go up in that far. This bottom of the plunger right here, okay, is never going to go farther than breaking distance up into the bottom of the slide. Okay, so it's not going to continuously go farther and farther. As it ends up going back and forth like this, the parts that are on the lower or the frame itself are going to stay inside of this channel. They're not going to go up into that hole. So that kind of gives you a better understanding of exactly how that's going to have to be modified, how that's going to have to be adjusted to work, and just a better understanding of why it causes problems. And that's the primary reason I took the time to build this for you, because I wanted you to see you can damage your optic by not doing it right. You know, recommendations are usually made to move the dovetail up front and then move this entire optic cut back here to stay away from having those issues. So guys, let's get back over to the CNC. We've got a lot of work that we have to do on the sides. We've got some stuff we're going to be cutting some pockets. We're going to be doing a window. We're going to be doing some front serrations. So we've got a lot of stuff that we still got to do here. We also got a front top window here, and we also have some chamfer work we still got to run down here. So let's get over to the CNC. Let's finish that stuff up. I'm going to go ahead and modify this plunger. Let's go ahead and get it all put back together and see exactly how it came out in the end. Need to end up running a correction right there. You can see that we have a Little bit of an issue here with the bit came down. We had a little bit of movement there. We hit the wall, so what we'll do is we'll do a positive clearance step over on that. So we'll go ahead and take off a couple thou, go ahead and clean that up and do that appropriately. The other thing we still have to do is the front and back tapering. So we're going to go ahead and we'll do a chamfer here, and then of course we'll do a chamfer on the back side. So once we go ahead and have those corrected, then we'll flip it over and we will repeat. Alright you guys, let's go through the process and see exactly how this came out in the end. Let's talk about the optic in the back first, and then we're going to move forward with the rest of the slide work. One of the reasons why we took this video a little bit slower, one of the reasons why this video was a little bit longer, was because I wanted to educate you guys just a little bit further on how that plays into effect when you start cutting a slide for a larger than normal optic. So you don't move the dovetail, you want to cut it between here and the plunger hole, we hit the plunger hole. Obviously we knew we were going to do that, we worked through those issues. The difference is that a lot of the times when you take your slide to your local guy, or maybe you mail it off and you're not quite sure if this guy's got reviews that you're mailing it to, at the end of the day, does he know that there's a problem? Are you letting him know that you want to put a Venom in there, or you want to put a Vortex in there, or maybe a Leopold or a Fastfire 3? Does he even tell you that we're going to hit the plunger hole? So that's one of the reasons why I think you guys come back, you watch this content, you guys are educating yourself a little bit further, you have a little bit better understanding of exactly what you want to have done and maybe how it should be done. So there's several reasons why I always encourage you guys to follow us, to go back, watch some of the older content. There's a lot of good information in there. Not every one of these videos at the end seems to be some kind of a show off. Sometimes we're not just reviewing the customer's slide, we're also learning something along the way from that start to that finish. We've actually gained a little bit of knowledge as we've progressively moved on with the project. So, you know, I'm always encouraging you guys to go back and watch stuff that maybe you haven't seen before if you're a newcomer. There's a lot of cool information there. And, you know, slow them down, watch them again, figure out exactly what you didn't know, and kind of just gain some knowledge over it. Now, let's talk about the top section here. I really like the top section, the way this is designed. So basically we ran a chamfer, then we went ahead and did some serrations on it, and then we went ahead and ran a chamfer on the hole, but only on the top side. So basically what that means is these pegs that are here, they've got a chamfer on the inside, okay? Not the hole, but just the pegs. And we also have a chamfer on the outside. So it's definitely a well thought out and designed plan. I really like the way that it came out, and I also like the way that the side, top, and then back to side flows. It's a very, very nice flowing pattern. We did run into a couple of issues with this design where, because we ran the same pattern on this side as we ran on this side, we ended up hitting some text here. We ended up hitting a little bit of the Glock logo text here. So it ended up one of those things where I had to do a text correction removal. A lot of the other companies that are out there just kind of leave it, or maybe they'll shave the entire side before they do that. So there's lots of different ways to fix it. Just make sure you're having it done right. Let them know that, hey, I don't want the text on there, or I want to have that corrected. And you know, they'll take the correct steps in order to remove that. So overall, I'm very pleased with the way that it came out. Obviously, this is my barrel. You guys have seen this before. This is my optic, and this is my lower. Now, these are the suppressor sights. One of the other things to take into consideration is, based off of the optic of choice, you need to make sure that we choose the correct suppressor sight height. The issue is that this ends up being one of the Ameriglow 329s, and it will not reach over the optic itself. Now, obviously the customer didn't know that when they shipped these to me. I didn't know exactly what suppressor sites were getting mailed to me because I installed them for free. So take that or keep that in mind, I guess. If you send me something, send me all the parts and I'll go ahead and assemble it for you. But that's going to have to be something that's going to end up being replaced in the end just because it's not high enough to actually see through the optic. So I usually make a recommendation of the Trigicons. They are more expensive, obviously, so they're a little bit different. It doesn't necessarily mean they're better. It just happens to be that most of them are a little bit higher than the AmeriGlows. AmeriGlow happens to make a lot of different styles, and we just need to make sure that you get the correct model in which will fit through the optic that you're using. So they're all cut the same depth, which still ends up being deeper than your plated MOS series because your plate, if you buy an MOS gun, basically it uses a plate there, which then raises the optic back up. Okay, so it looks to be really, really low on an MOS, but then you got to think, well, there's a plate that goes there. Then the optic goes on top of the plate. So at the end of the day, it's not quite as low as you would think. These are all cut to the same depth is what would be the industry standard, I guess, is so-called, or so to speak. I guess that's the best way to say that. So. But definitely make sure you get the right hardware for something like that. If you're taking into consideration a build, it's easy. It's very easy for a mistake to be made, especially if you're not 100% sure which one to order or which one to buy. It only takes a second to buy something and all of a sudden it just doesn't flow right. The other thing that you're going to notice is up here on the front, I left this stud right here, this third one over. I guess it's not really a stud. This first one wasn't anything. It's the second one here. I left it over so that way the optic itself would rest on a top side and not on a bottom side. So paying attention to detail can go a long ways, especially when you're looking at the longevity of a build that maybe you're going to keep. There's a lot of detail that goes in the side, top side, back, frame kind of thing. So just take that into consideration when you're looking for somebody to do the work for you. Just make sure that you're buying into the right person to do the right work for you. There's lots of companies out there that just run the same thing over and over and over again. They really don't care. And then there's other people like myself, there's several of us out there, that end up doing individual projects based off of the customer's needs, and we blend them together and we kind of put them together overall and kind of do this big collage of their vision. So just make sure you buy into the right person in order to for them to build the correct collage, so to speak, for you. So. All right, guys, well, hopefully you enjoyed that content. That was something that we have not done before. I definitely want to take the time and show you how that plunger can play into the effect of not functioning. Okay, so we have issues where beating on the bottom of the optic, having other issues like causing problems with cycling because the plunger doesn't go up in, so we're not getting that extracting that we should be getting. So I'm hopefully that encourage some of you guys to have a better understanding of exactly how that all works together. This was one of the ones that I put together, and I did not do a build video on it, so I wanted to show it to you real quick. This ends up being a 43 with the Raptor cuts. Just beautiful overall. This is your graphite black, real silky, smooth on the outside, just really pleasing. Punisher logo on the back rear section, and then of course we ran the Hive on the rear grip. So definitely an overall really cool build. Probably enough content here to have actually turned this into a build video. Unfortunately, I've just been really busy lately, and I've been turning out work and not necessarily showing all of the work. So I would encourage you guys to always follow through to the ends of my videos, because that's where you're probably going to see something that honestly, we might not have even discussed before. It might just kind of show up. One of the other reasons I encourage you guys to go over to our Instagram and follow us over there. We have a lot of cool things going on over there. This is usually where you're going to find that content. Sometimes there's not a build video. There just happens to be a product in hand at the end. And you get to kind of see that final work or that craftsmanship. So that's kind of cool. Definitely follow us over there. And then we also have Facebook. We know a lot of you guys that don't do Instagram, so a lot of that content ends up getting posted back over on Facebook. We basically just tag the same content, so we post it on Instagram and it gets double over there onto the Facebook account. Very cool as well. But if you have any questions about anything, feel free to go to the webpage. There is a contacts tab. Go there and fill out the information. Let us know exactly what you're looking for. Tell us what you want to have done as your project, and we'll try to work through each and every little aspect of that until we come down to the final quote and the nitty-gritty of exactly what we decided to do. And then we'll get your project started and we'll get that turned out back to you. So guys, thanks for everything. If you have any questions, let me know.